Hello everyone, welcome to class number 3 of DSG models. Remember, we are trying to solve a real business cycle model. We have discussed what are the differences between non-Keynesian and new Keynesian models. We have talked about how to set up the real business cycle model and how to solve for the households maximization problem. So now we're going to take a look at the firm's problem. I would like to let you know there's a link in the description where you will be able to find the outline of the course in my website with all the tutorials and the descriptions as well. And you also have a link where you will be able to buy the material in case you are interested about that. It will include the paper, the slides, and also this data do file along with the dataset. So let's begin now with the class for today. So the following topics are going to be discussed today. Is first, we're going to start with the role of the firms in the economy. We're going to take a look at what's the firm's production function. We're going to take a look at the budget constraint. And finally, as we did with the households problem, we're going to be solving by hand the maximization problem of the firms. So as we mentioned before, in our economy, firms are going to be producing the final goods and services that the families are going to consume in this economy. In order to produce, they are going to require capital and labor. They are going to demand their inputs to the families, and they are going to be paying salaries for every hour that the families are working, and they are going to be paying returns on the capital that they are getting from the families. Finally, in this setting, we are going to assume perfect competition, so the profits will be equal to zero. Let's start by taking a look at the firm's production function. We're going to be using the normal Cobb-Douglas production function, where Y stands for the output that the firm is producing, KT is the capital, the HT are the hours work. You can also assume this is labor. There are some papers or some other type of settings where instead of using an H, they use L. That's fine. It's still the same. We're talking about labor. And the alpha is the share of the input. So we have a share of capital, and we have also the rest is going to be the share of work. Finally, we have the AT in here, which is a stochastic productivity shock, which is going to follow a first order autoregressive process. So recall that we have mentioned before that the sources of fluctuation in business cycles for real business cycle models are coming from shocks in the productivity of the firms. We said that in moments where the productivity or the technology expands, business cycles expand, and also when the technology starts to diminish, then the cycles start to contract. So all we are going to say that in these type of models is that the source of fluctuation is going to be coming from shocks on the productivity, which is following a first order autoregressive process, and it's very important that it's going to follow a normal distribution. Let's take a look at the firm's budget constraint. So we have mentioned the firms are going to be producing output, they will demand labor and capital, but then they have to pay for these inputs, right? So what they are going to be paying then is for each hour of labor or work that they are getting from the families, they are paying a wage. And for every unit of capital they demand to the families, they are going to be paying a return. So basically, this is going to be the budget constraint of the firms, the salaries and the returns that they are paying on capital. So what is the maximization problem that the firms are facing to maximize their profits? It's basically the following. We have the Cobb-Douglas production function subject to the budget constraint, and then we have that the final problem can be solved the following way. So again, we're going to go into the board and we'll be working with the first order conditions, and we'll be getting to the optimal decisions that the firms are doing to produce their output. To solve the maximization problem of the firms, we need to maximize two variables. We are talking about the capital, and also we are talking about the hours work or the labor. So what we need to do then is to take the first order conditions with respect to the profit function from with respects to capital, and from here what we'll get is that the first order conditions then is alpha at kt alpha minus 1 ht 1 minus alpha. And then the other place where we have capital is here. So the derivative with respect to capital E here would be minus RT. And then we'll have to do the same, but with respect to the hours worked. So I'm going to take the first order conditions with respect to the hours worked. So here we have an HT. So if we take the first order conditions, we'll be left with 1 minus alpha AT KT alpha, and then here we have HT 1 minus alpha minus 1. Okay, and the next HT that we have is in here, so the derivative with respect to HT would be WT. So basically these are the first order conditions. Now we can work a little bit more in here. So I'm going to just make an arrow. We'll keep working on here. We're going to solve for RT, which is the returns. And this would be the following. RT is going to be equal to alpha AT KT alpha minus 1, and this is HT 1 minus alpha. Perfect. So basically this is going to be the first conclusion that we derive from here, and the following is going to be true for WT. So WT, which remember are the wages, is going to be equal to 1 minus alpha AT KT alpha, and then we have HT, and then we can just write, we can cancel these terms, we can just write minus alpha. Let me show you now a last step that we can do to clean a bit more the numbers. So then it's going to be easier when we have to write all the equations in the software. So from the first conclusion that we had derived was the returns is going to be equal to this. So if we take a look, what we can do in here is we can do the following. We can let the KT, we can do this. We can do KT alpha times KT minus 1. Yes, because that's what we had in there. It's the same to doing this times HT 1 minus alpha. So now what we can do is the following. This minus 1 means that we can put this as a denominator, yes, as dividing. So we can do the following. We are left that the following is going to be true. KT alpha HT 1 minus alpha, and then we can just put that KT in here. Okay, so why we did this? Because we have the minus 1 in here, so it's the same to just putting this dividing. If you take a look, I'm gonna pick another color. I'm gonna go with green. If you take a look at the numerator is basically the production function. As you can see here, it's AT KT alpha HT 1 minus alpha. So in summary, what we can do with RT is call it alpha times YT over KT. So this is our final conclusion. So all we did was just clean a bit more the numbers. So this is more straightforward when we write the equations in the software. So this is what we're gonna call then the conclusion number 1 from the firms. We are getting the returns on the capital. Let's do the same analysis now for wages. We're going to do the same math in here that we did for returns. we are just gonna copy this way. Here I am missing an alpha. There we go. So we are just going to write kt alpha, and then we are going to write ht 1 minus alpha times ht to the power of minus 1. So as we did before, we can put the ht dividing then. So we'll just copy this part, kt alpha ht 1 minus alpha, and this divided the ht. And the last thing, as we did before, I just grab the green, I circle, and this part is the same in the production function. So what we can do then is just rewrite the equation as 1 minus alpha times yt over ht. So in the end, this is going to be the other dynamic equation that we want to keep track of, because we're going to need these at the end. When we get to the general equilibrium, we're going to need this equation, and we're going to need as well, remember, I'm just going to write it in here. Equation 1 was RT, which was just alpha YT over KT. So these are the two final conclusions that we get from the firm's maximization problem. We're getting the wages and the returns. So these two dynamic equations, we're going to keep them aside, and we're going to use them back when we get to the general equilibrium. That's going to be all for today. I hope you found this video useful. I would like to invite you to subscribe to my channel if you would like to get notified when I submit my next video. We're going to be getting to the general equilibrium, and also we're going to be writing all the dynamic equations into the software, which I'm going to be using Stata, and we are going to be getting to the steady state, producing some impulse response functions, and also some out of sample forecasts. So once again, thank you very much for watching.